Ever wondered if we can predict the future? Let's dive into the fascinating clash between determinism and quantum mechanics. First, determinism. The idea that everything unfolds like clockwork. If we know the present state of the universe and the laws of physics, we can predict the future with absolute precision. This concept was famously championed by Pierre-Simon Laplace. Imagine his Laplace's demon, an all-knowing intellect that can calculate the future based on the present. Intriguing, right? But hold on, quantum mechanics enters the scene and shakes things up. At the heart of this theory is the Heisenberg Uncertainty Principle, proposed by Werner Heisenberg in the 1920s. It tells us that we can't precisely measure certain pairs of physical properties at the same time. For instance, position and momentum. The more accurately we know a particle's position, the less precisely we can know its momentum, and vice versa. Similarly, there's an inherent uncertainty between energy and time. Now, determinism faces a big challenge with the quantum measurement problem. In quantum mechanics, measurement collapses the wave function into a definite state. But the Schrödinger equation, the backbone of quantum mechanics, doesn't explain this collapse. Laplace's determinism relies on predictability, but quantum measurement introduces randomness. Can we ever reconcile these views? Then there's quantum entanglement. Particles can become intertwined, their properties linked even across vast distances. Einstein called it spooky action at a distance. This phenomenon challenges determinism by suggesting information can propagate faster than light, breaking classical causality. And let's not forget quantum gravity. Unifying quantum mechanics with general relativity, our theory of gravity, remains a huge puzzle. Laplace's demon would need a theory that unifies all forces, from the smallest scales to the cosmic. Some physicists propose hidden variables to restore determinism. Yet, Bell's theorem throws a wrench into that idea by suggesting no local hidden variables can explain quantum correlations. Non-local hidden variables, still speculative. Quantum decoherence might offer a glimmer of hope. When quantum systems interact with their environment, superpositions collapse into classical states. If we could control decoherence, maybe we could mitigate uncertainty, but it's easier said than done. So, can we predict the future? The quest continues. Reconciliation refers to the process of harmonizing or resolving differences between two opposing ideas, theories, or viewpoints. It often involves finding common ground, bridging gaps, and creating a cohesive understanding. In scientific research, reconciliation occurs when seemingly contradictory theories are integrated or modified to form a unified framework. Philosophers seek reconciliation between conflicting philosophical positions, such as free will versus determinism. And on a more personal level, reconciliation between individuals involves healing rifts, forgiving, and restoring trust. One of the most ambitious scientific endeavors today is the attempt to reconcile quantum mechanics and general relativity into a single theory of quantum gravity. This unification would address the inconsistencies between the physics governing the very small and the very large, providing a more complete understanding of the universe. In personal relationships, reconciliation often follows disagreements or conflicts. It involves open communication, empathy, and compromise, ultimately leading to a stronger, more resilient bond. Challenges. Reconciliation isn't always straightforward. It requires intellectual flexibility, patience, and a willingness to explore new perspectives. Scientists must be open to modifying or even abandoning cherished theories in the face of new evidence. Similarly, individuals must be willing to let go of grudges and approach each other with genuine intent to understand and heal. Despite the challenges, reconciliation fosters growth, understanding, and progress. In science, it allows us to transcend the limitations of current paradigms and move closer to a unified theory of everything. In personal relationships, it enables us to move beyond conflicts and find common purpose, strengthening our connections and enriching our lives. Let's delve into the concept of reconciliation and how it plays a pivotal role in harmonizing these seemingly opposing ideas. Reconciling determinism and free will is a fascinating philosophical endeavor. Let's explore how these seemingly opposing concepts can coexist. Compatibilism, also known as soft determinism, asserts that free will and moral responsibility can coexist with the truth of determinism. Compatibilists subtly revise or redefine the common-sense notion of free will to make it compatible with their deterministic world. While the universe operates deterministically, our understanding of free will adapts to accommodate this reality. Free will. Free will involves the power or ability to make choices for which we can be held morally responsible. It confers moral responsibility and distinguishes mature persons from animals and children. Our ability to hold others accountable, with gratitude, love, respect, resentment, indignation, and forgiveness, depends on regarding them as responsible agents. Determinism posits that the universe's future is fixed based on its present state and the laws of physics. Initially, determinism held sway, but quantum theory introduced a degree of randomness at the microscopic level. Some physicists still seek hidden variables to reintroduce complete determinism. Reconciliation compatibilists argue that even in a determined world, a lesser form of freedom exists, one consistent with moral responsibility. Rather than relying on indeterminacy and chance, determinism, according to some, provides a better account of free will. So whether we are reconciling grand scientific theories or mending personal relationships, the process of reconciliation is essential for progress and unity.